Welcome, my dear students. So today we'll discuss some of the questions from exercise 8.44 from the NCERT textbook class 10. Okay, so one of the question given in 8.4 was write all the other trigonometric ratios of angle A in terms of sec A. That means what? Cos you have to write in terms of sec, sine, cot, tan, cosec. All the other 5 ratios you have to write in terms of sec A. Now how to start? You can start in different ways. So here what I have done, since I know or you all know that the reciprocal of sec is cos, so we will start with cos. Okay, so cos A is equal to 1 by sec A because of the reciprocal. Okay, next sine. We know sine is directly related to cos. If you see the trigonometric identity, you will get that sine square A plus cos square is equal to 1. From here, if you deduct, you will get sine A is equal to 1 root over 1 minus cos square A. Since we know the cos A in terms of sec A, we can substitute that. So cos square A, if you write in place of cos 1 by sec A, it will become 1 by sec A whole square, and that whole square will change to 1 by sec A whole square. This one you can write 1 square means 1 and sec A whole square means sec square A. Again taking LCM, since here you have 1, so LCM will be sec square A, so sec square into 1 sec square A minus 1. Now you can take root of this term, so it will root over sec square minus 1, but sec square A, root over of sec square A is equal to sec A. So now sine is also being expressed of in terms of sec A. Next cosec A. Since cosec A, the reciprocal of cosec A is equal to 1 by sine A. Sine A and cosec A are reciprocals, and we have just now found sine A, so we'll get cosec A is equal to reciprocal of this, so sec A by root over sec square A minus 1. Okay, now we are left with two ratios, tan A and cot A. Now again, since we have a direct relations between sec and tan, that is, what was the relation? That is sec square A is equal to 1 plus tan square A. So here easily you can express tan in terms of sec A. Now 1 if you bring minus, so sec square A minus 1 is equal to tan square A. Since we need tan, so square if you change, it will become tan A is equal to root over sec square A minus 1. Again tan and cot are reciprocal of each other, therefore cot A is reciprocal of tan A, that is reciprocal of this 1 by root over sec square A. In this way you can change any 5 trigonometric ratios to one of them. For example, you can change other trigonometric ratio to cos A, or any other ratios you can change. Okay, so this is one of the questions given in the textbook. Clear? Okay, so or you can start in this way also. Since here you have to explain sec A, so first see what is the direct which identity is directly related to this term. Since we know tan and sec are directly related, so you can find tan A, that is root over sec square A minus 1. Already I have found shown you the derivatives, and if you know tan A, easily you can find cot A because they are reciprocal. Okay, again you can take the reciprocal of sec A, which is cos A, so you can find cos A. Again cos A and sine A, they are directly related to each other, so simplifying same way, you can find sec A is equal to this. Again sec A is reciprocal of cosec A, so you can easily find cosec A. In this way you can solve. Clear? Next we'll try to solve some of the trigonometric equations. Already I have shown you some of my observations or my mathematical approach to trigonometric equations. So same thing I will elaborate here too. So first was to identify the complex side. So here if you see, more or less this side is more complex than the other side. Okay, we'll start from here. So second point, what was that, is change to sine and cos if you are not able to apply the trigonometric identity directly. Here, since we cannot apply trigonometric identity directly, so we will change to sine and cos. Okay, so you know tan is equal to sine by cos and cot is equal to cos by sine. So after applying trigonometric identity, and here in the numerator we have sine by cos, let it be same. In the denominator, here 1 minus cos theta by sine theta, this you can simplify with the help of LCM. So you take LCM, sine theta, then 1 into sine theta is equal to sine theta minus cos theta. Similarly, other side also being simplified. Again, you know, when you have fractions like this, a by b is equal to c by d, how to write this? Numerator you will be writing as it is, and denominator you will be writing by multiplying the reciprocal of the denominator. Same thing I have done here. Numerator same, sine theta by cos theta. Denominator I have multiplied by taking reciprocal, that is sine theta by sine theta minus cos theta. Same I have done here. Okay, so when we have discussed last video about my approach to trigonometric equations, so one was complex side, other was changing to sine and cos if identities are not available, and next was rationalize. And also one of the point I have highlighted on the video is that common. Whenever you see something common, take the common out. Now if you observe carefully in this step, so this part you can take common, though it is given there sine theta minus cos theta, and here is cos theta minus sine theta, but we can express it as sine theta minus cos theta. How? Using this identity. So a minus b is equal to b minus a. You can take minus common, so their side can be changed. Okay, now same thing I have done here. See here, so this one sine theta into sine theta, sine square theta, cos theta into cos theta, cos square theta, and same thing I wrote here. Now I want to take common, but before taking common, here it is cos minus theta. I want to make it sine theta minus cos theta. For that I will take minus common, and this minus and this plus will become minus, then this sine will come here and cos will go there, so sine theta minus cos. Now in the denominator we have this sine theta minus cos theta. So whenever you take anything common from the denominator, so make sure you write 1 by. Okay, if you have no common in numerator, write 1 by. So this is taken common, then you have sine square theta by cos square theta minus cos square theta by sine square theta. Okay, you have this. Now after this, you know, here you can see here, so if you take LCM will be cos theta into sine theta, and this sine theta you have to multiply here, and cos theta you have to multiply here, like cross multiply. So in the it was sine square theta, it will become cos cube theta minus sine cube theta minus cos cube theta by sine theta into cos theta. Now here what you have to do, you have to use algebraic identity a cube minus b cube, and identity was a minus b into a square plus ab plus b square. This algebraic identity you have to apply to simplify further. So a minus b, a square plus ab plus b square, same identity I have applied, and I wrote this. Now if you see, this factor and this factor are same, so you can cancel from numerator and denominator. So cancel, then you will have this sine square plus sine theta into cos theta plus cos square theta, but sine square theta plus cos square theta is equal to 1. So here this one came because of sine square theta plus cos square theta. Then we have this. Now you will distribute in this way 1 by this denominator plus sine theta into cos theta by this denominator. Then you have this. Okay, now you know 1 by sine into cos, you can write 1 by sine theta into 1 by cos theta, and 1 by sine theta, the reciprocal of sine is cosec and reciprocal of cos is sec, plus 1, which is your RHS. Next concept will be rationalize. You can use the rationalize trick. Okay, here rationalize tricks means what? If we have a plus b, then what we are multiplying? A minus b. if we have a minus b, then we are multiplying a plus b. So this is called a rationalist concept. Okay, so let us say this is rationalist concept. So we will apply the rationalist concept to solve this. Okay, we have root over 1 plus sin a, 1 minus sin a. Now if you see, this side is more complex, so let us start from the complex side. No doubt you can start from here also. Clear? So let us start from here. Now what we do, we have 1 plus sin a by 1 minus sin a. So we will use this rationalized trick. Okay, so in down we have 1 minus sin a. See, this rationalized trick you can apply in numerator as well. According to the questions, if applying rationalized trick in numerator, it is easy, you apply in numerator. Now here I am applying rationalized trick in the denominator. Why? I will explain at last of the video, so watch the video. So here I have applied 1 plus sin a, and so this one I have to multiply up and down. Okay, afterwards what we get, you will have this root over 1 plus sin a whole square, then it was in this position sin a 1 plus sin a, which is 1 minus sin square a. Okay, now if you see the trigonometric identity, 1 minus sin square a is equal to what? Cos square a. Now root over of 1 plus sin a whole square is 1 plus sin a, and root over of cos square a is cos a. Now you distribute the denominator, so you have 1 by cos a plus sin a by cos a. Then reciprocal of cos is sec, so 1 by cos a is equal to sec a, and sin a cos a means tan a, so plus tan a, which is equal to RHS. Okay, so this here I have used rationalist trick. Next, let us see how you can use identity. Okay, identity trick. Now if you want to solve these equations, now see, this is more complex compared to this. Having root over we take is complex. Now since we have to change to sin and cos, sorry, this is not cos, it should be cot theta. Since we have to RHS, we have to prove tan and cot, and we know that sec is directly related to tan and cosec is directly related to cot. So let us take the identity of sec square theta and cosec square theta. So sec square theta is 1 plus tan square theta, and cosec square theta is 1 plus cot square theta. Now 1 plus 1 is equal to 2, then you have tan square theta plus cot square theta plus 2. Again, since tan and cot are reciprocal of each other, and you know when you are multiplying two reciprocal numbers, answer is 1. 2 by 3 into 3 by 2, they are reciprocal, so answer is always 1. So in place of this there is 1, in place of this 1 we can write tan theta cot theta. Now it becomes a square b square plus twice ab, that means a plus b whole square. Now this square will be cancelled by this root over, then we have tan theta plus cot theta equal to RHS. Okay, so this is an idea where you can use direct identity without changing to sin and cos. Okay, let us see one more example for direct. Okay, identity. So here also the same direct pattern identity. Here also, if you see, this side is more complex than this. Let us start from the complex side. Already I have discussed the complex. What does complex mean for me in the previous video. Okay, basic approach, mathematical approach to trigonometry. You can watch that video. So cos minus sin a plus 1 by cos a plus sin a. Already this expression is in sin and cos, but if you observe carefully and try to apply, we don't have suitable, though we have formula between sin and cos, after applying we will not be able to easily simplify the expression. So what we'll do, since we'll take in this way, since cosec and cot a, they have direct identity, that is cosec square a is equal to 1 plus cot square a. Let us try to apply this identity. For that, this cos and sine should be changed to cosec and cot. Okay, for that what we do, we divide numerator and denominator by sine. Why by sine? Because if you divide cos by sine, this will be cot and this will be 1 and this will be cosec. That means everything is changed to cos and cot. Similarly, since we have divided numerator by sine, same thing you have to do in denominator also. You have to divide by sine. Okay, after that you will get this expression. Okay, now this is a pattern, this type of pattern. Here, to simplify this, what we'll do, since we need to prove this expression, trigonometric expression, will multiply both in numerator and denominator. There are some other approach also you can apply. You can apply, instead of multiplying cosec a plus cot a by this trigonometric expression, you can simplify this by replacing this 1 from here. Okay, you can find the 1 from here, and by replacing the 1 here, this one, if you replace, then also you will get the answer. Okay, now after multiplying, let us keep the first numerator same as it is, because I want the answer to come cosec a plus cot a. I want this expression should be cancelled. Okay, now in denominator what we'll do, we'll arrange the term in this way. This will come here minus cosec a, and this is plus cot a plus 1. Now from here I will take minus common. If I take minus common, this negative will become positive and positive will become negative. Now we'll distribute. So this I will take as one term after taking minus, and this another. Now applying distributive property, if you multiply this 2, then we have, taking minus out, we have this, and this into 1 gives this. Now this is what? A minus b, a plus b. That means a square minus b square, a square minus b square. Now if you apply this identity, what will be cosec square minus cot square a? It will be 1. So apply here 1. Then what we'll get? See, we have minus 1. In numerator we have kept as it is, not changed. So here minus 1 plus cosec a plus cot a. Now if you see this factor and this factor, see minus 1 cosec a plus cosec a plus cosec a plus cot a plus, so these two factor cancel, then we have cosec a plus cot a. Okay, so this is a little critical one, but when you practice you'll find it very easy. Okay, so these are the two questions which I have solved based on the identity. Sometime without changing to sin and cos, you can apply direct identity to solve. Okay, so in between I have said that I will show you why I have taken here. Where is the video? Okay, I've said you why I have taken, means multiplied here by 1 by sin a, 1 by sin a, 1 by sin a. Okay, why I have used this rationalize. So I could have used here also 1 minus sin a. Why not here and why here? Because see the RHS part. Sometimes when you solve LHS, so if you simplify little few steps from the RHS also, then it will be very easy. Now since I have expressed in sin and cos, if I express this RHS in sin and cos, it will come 1 by cos plus 1 by sin, so 1 plus sin by cos. So down I need cos, and I know if I have sin 1 minus sin square a, then I can get cos square a. For that reason, to get a square minus b square identity, I have rationalized in the denominator, not in the numerator. In this way you can check, which will be helping you to further simplify. Okay, thank you.